Hi everyone, I am Soumojit Chatterjee and this is TLE Eliminators. Welcome to the post-contest discussion of today's Codechef contest. We will discuss the first 4 problems of Div 2 today. So without making any delay, let's begin. Okay, so this was the first problem of the contest. It says streak star. So the question is that the streak value of an array B is defined as the maximum length of a non-decreasing subarray. Okay, and chef has an array A of length n and a magical number x. You are allowed to perform the following operation at most once. So what is the operation? The operation says that select an index I and update the element at AI by multiplying it with x. That is, set AI to AI times x. Your task is to find the maximum possible streak value achievable for array A. Okay, fine. So let me explain the problem statement once. So the question says that as a part of the input, we will be given an array of integers a1 to an. Fine. Now the question also says that what is the streak value of an array? So the question asks that what is streak value of an array? So it says that in an array, the maximum length of a subarray. So suppose you have an array a1, a2 to an. So the maximum length of a subarray, of a contiguous subarray, which is non-decreasing. So suppose I call a subarray non-decreasing if all the values are basically the previous values, the left values are less than equal to the right values. So for example, a subarray ai to aj, this can be called non-decreasing if ai is less than equal to ai plus 1 and it goes till aj. Fine. And the question says that the streak value of an array is the largest such subarray which is non-decreasing. Great. Now the question also mentions about a special number x. So apart from this array, it also gives x as input. And the question asks that if you have the power to take any one element of this array and multiply it with x. So for example, you replace a2 with a2 into x. Then by doing this operation at most once on any of the elements, what is the maximum possible streak value you can make? So that is the question. Now there is something very interesting to note in the question. Like if you realize, the question says that the sum of n overall test cases won't exceed 1000. That means if the sum of n overall test cases does not exceed 1000, so constraints are usually a very good hint to solve the problem. If it has been said that the summation of n does not exceed 1000, that means an order n square code is acceptable, right? So an order n square code will also give AC. So if that is the case, what is the how can we think of a solution? First of all, forget about this operation. So the question says that okay, we can take any one element and we can replace it with, we can multiply it with x and then find the streak value, and we have to take the maximum of them, right? So forget about this operation. First of all, let us try to understand that okay, if some array is given, how can I calculate its streak value? So if there is some array suppose given to me, so an array a1 to an is given to me, how can I calculate its streak value? So how can I calculate its streak value? You must realize that basically what happens if I plot these values over some graph. So suppose this is the graph and I am trying to plot these values. So suppose this is a1 and the value increased to something, say a2, it again increased to a3, then it decreased to a4, then suppose it increased to a5. This is how a general array looks like, right? So look that this part of the subarray a1 to a3 is a non-decreasing subarray. Similarly, a4 to a5 is a non-decreasing subarray. So that means we can divide an array into multiple chunks, right? And all these chunks are non-decreasing, and we have to find the maximum length of them. That is basically what the streak is. So that means we can run a simple for loop or run a loop from I equal to 1 to n and check that okay, is my current element greater than equal to the previous element? If the value of the current element is greater than equal to the previous element, that means we are part of this same chunk, right? And we can keep on increasing the length of this chunk. And as soon as the value decreases, like from A3 to A4 this value decreases, that means my previous chunk has finished and I have to start a new chunk now. So that means how can I calculate the streak of some array? So suppose I need to calculate streak. So my idea is that why not run a loop for I equal to 1 to n. Okay. Now when I am running a loop, let me also maintain a variable, say previous. This maintains that what is the previous value I have seen. Fine. Now if I see that okay, if my vi value is greater than equal to this previous value, that means I can increase my length plus plus. That basically means that okay, if the value of vi is greater than equal to previous, then this chunk is basically increasing. So that means I have non-decreasing a larger non-decreasing chunk, right? So I make it len plus plus. Fine. Now, apart from this, also what I need to do, I need to update the value of priv to this vi, right? And if this is not the case, that means the value of vi is less than the previous value. So that means what has happened? So things were increasing, and then suddenly increasing, and then suddenly it decreased. So that means we have to start a new chunk. So that the length which we have accumulated has finished, and now we have to start again from length equal to 1, right? So in that case, what we can do is we can simply again start from length equal to 1, and we can set same our priv, this priv value to equal to vi, and we need to take, and suppose we need to store the answer which is the maximum of all lengths which we have got, right? So before forgetting this previous length, so before resetting the length again to 1 and before forgetting the previous length, what we can do, we can basically take the maximum of it. So basically we do answer of max comma answer and len. So what does this do? This basically, so answer is basically the maximum of all lengths you can get. Fine. So using this algorithm, what do we do? Basically we are given an array a1 to an. We do nothing but we break this array into multiple chunks, all of which are non-decreasing, and then we calculate all of their lengths. So we calculate all of their lengths and then we take the maximum of them and store it as the answer. That is what the streak value of an array is, right? So using this we can actually find the streak value of an array, and that is clear. But the question was something different. The question said that we can do an operation. What operation was that? So the question said that if you have an array of integers, say you have a1, a2 and so on, you can take some element ai and rewrite it to ai times x, right? And then we need to find the maximum streak value. We can do this operation at most once. That is given in the question. So don't you think that okay, since order n square code is allowed, and what is the time complexity of this streak finding algorithm? So in order to find streak, we basically run an algorithm which iterates over the loop array only once, right? So the algorithm of this streak finding time complexity of this streak finding algorithm is order n. Great. And order n square code is allowed. That means what we can do is we can simply check over all operations one by one, isn't it? Like first of all, try increasing this value, overwriting this a1 with a1 times x, and then try to find the streak. Then do the same thing with a2. Do the same thing with all these elements. So what do I mean basically is that suppose I have been given this array a1 to an. Then basically look at all these arrays. Look at this array a1 into x, a2 and an, so on. Similarly, keep a1 fixed and take a2 into x and an, so on. So basically try multiplying all these elements a1, a2 into x once, right? So you will get n such cases. Find the streak for every one of them. So that will take order n time. So in order n squared time, you can find the streak of all these arrays, and then you can actually compare which one is the maximum. Isn't that that makes sense, right? So even if you look at the code, that is exactly what I've done. So this is the code to the problem. If you look into it, so this is a function I have written which basically finds the streak value of a vector. Look very clearly what I have done. I have basically iterated from I equal to 0 to n. Just like as I explained, that if I see that okay, the value of that the current value is greater than equal to the previous value, I just increase my len variable. So that basically means that my current chunk length has increased by 1, right? And if I see that the value of vi is less than prev, then that basically means that I have to start a new chunk. So I reset my len value to 1, and I take answer to be the maximum of the answer and this len, because this len is also a valid non-decreasing array, sub-array, right? And finally we return answer, and that is basically the streak value of a vector v. Fine. And then what do we do? In order to simulate the operations, I go into all elements one by one, I multiply that value by x, and then basically check that okay, what is the maximum, what is the streak value I can get, and take the maximum of them. Fine. And then remember that when I'm multiplying a value with x, I have to divide that value with x again, so that in the next iteration we get the original value back. So this is basically something like this, that when you started with a1, right? So you multiplied it with x to get a1 into x, and then you found out the streak value of this array. So that is completely fine. But now when you will move from I equal to 0 to I equal to 1, and when you multiply this a2 to get a2 into x, you need the original a1 back. So the thing which you have multiplied with x, you again divide it with x to get the original value back, so that in the next iterations you do not work with the updated value, rather you work with the original value, right? So that is the reason I multiply once, I calculate the streak, and then I again divide it, so that for the next operations we can handle the original value only. Fine. So that is what the algorithm is, and I hope that the assumption that the explanation is clear. So now if that is clear, let us move to the next problem of the contest. So the question says transform string. So the question says that chef gives you two strings a and b. You can perform the following operation on a as many times as you want. What is the operation? It says that remove character ai from the string a. This has a cost of I, which is the index of the element that you are removing. Okay, just a second. Yeah. So remove character ai from the string a, and this has a cost of I, which is the index of the element that you are removing. Fine. The question says that the cost is always equal to the index in current string and not the original string. Great. You have to print the minimum cost of transforming a to b using the above operation. If it is not possible to transform the string a to b, then print -1. Great. So now let me explain the question first. So the question says that you are given two strings a and b. So the input to the problem is two strings a and b. So a may be some large string, and then b, and then there is b is some smaller string. We have to remove elements from a so that it finally matches with b. Now there is a cost involved when you basically remove elements from a. So just for the sake of some example, so let us take one example from the test cases only. So okay, this one is a nice example. So it says a, c, c, d and c, d. So the question says that you are given two strings. The string a is this string a, c, c, d, and the string b is the string c, d. Fine. Now basically the question says that you have to delete elements from this string a to finally get b. Okay. Now what is the cost of deleting a character? It basically says that the cost of deleting a character is basically equal to the index of that character. For example, if you have this ACCD, you can delete this C, right? You can delete this C and you get a new string ACD. So what is the cost you incorporate when deleting this? Since it's index, if you look at one base indexing, this index is 3. So you actually incorporate a cost of 3 to delete this character and get ACD. Then you can now choose to delete A. It has an index of 1. So you add one more cost to finally get the string CD. Right. So the total cost you incur from A to get B is 4. Right. There may be multiple ways to do so, and we have to print the minimum cost required to convert A to B. What do you mean by minimum cost? Like for this same example, let me again take A, C, C, D, and B is CD. Now let me show you one more set of operations. So let me first delete A. So if I delete A, I basically incur a cost of 1 and I get the new string which is CCD, right? Fine. Now let me delete C again. If I delete C again, then I again incur a cost of 1 and now the new string which I get is CD, which is basically equal to B. So in this case, we incur a cost of just 2. So note that in order to get the final string B, there may be multiple possible sequence of operations where you can take different costs. Say here it took a cost of 4, but here to do the same thing it took a cost of 2, and we have to basically print the minimum cost required to convert A to B. So how can we do that? Okay, now this question is fairly intuitive. Like if you think about it, like think about these strings A, C, C, D, and think about this C and D. Now note that if you have to minimize the cost, to convert A to B, it always makes sense deleting lefter characters, right? Like if you have these two C, it always makes sense to delete this C. Because if you delete this C, its index is smaller, right? The index of this C is 2, while the index of this C is 3. So that means it always makes sense to delete a character of smaller index. If you delete a character of smaller index, there are chances that you will incur lower cost, right? Now think about this. You have to finally delete some characters from A to get B, right? So that means B must be a subsequence of A, right? So you have to basically map every character of B with some character of A. You have to map every character of B with some character of A, and then you have to delete all the remaining characters, right? Like take any example. So let me take for example the string Bombay. Suppose this is A. So suppose A is the string Bombay and B is the string Bob. Fine. So basically what happens is that there exists a matching between the characters of B and the characters of A, right? What you need to do is you have to maintain this matching, and for all other characters you have to remove them, right? Now what I have already discussed, that what would be the most intelligent way to remove characters? You always remove characters from the left first, because if you remove characters from the left first, then you would always ensure that the cost is minimum, right? So that means we have to insert characters from the left first. Okay, that makes sense. But now think about this. Suppose I have this string B A B B. Fine. And suppose this is my string A, and I have this one more string B, which basically has only one character, which is B. So now there are multiple choices where this B can get matched to. Like this B can get matched here, this B can get matched here, this B can get matched here. Like, right? So there are multiple choices where this B can go and match to. If this B gets matched to this first B, then we have to delete all these remaining characters. Similarly, if this B gets matched to this B, we have to delete all these remaining characters. And among those, we need to pick that set of operations which actually minimizes or keeps the cost minimum. Fine. Now think about this. It always makes sense to match B with the rightmost possible character. Because if I match B with the rightmost possible character, it will always ensure that the cost is minimum. Why? Think about it. Let us take an example. So let me take So let me take this first example where B is matched with this B. Fine. So if B is matched with this B, so let us take this example. So let me erase this part and this part. Okay, so this is my B, and suppose B is matched with this B. In that case, what is the cost I need to incur? I will always delete from left to right. That we have already discussed, that deleting from left to right is optimal. So I first delete this. If I delete that, the first characters, I get a cost of 1. Then I again delete this. So I again get a cost of 1. And now I have to come and delete this, and this will be a cost of 2, right? Because when I will delete this, the string is basically BB, and I have to delete this, it is at index 2. So my cost will be 2 here. Fine. So the total cost will be 4. Now think what will happen if instead of mapping B to this B, I map B to the rightmost B. So in that case, I will first delete this B. This will have a cost of 1. Then I will delete this A. This will have a cost of 1 again. Then I will delete this B. This will again have a cost of 1. So in this case, the total cost which I need to incorporate is 1 plus 1 plus 1, which is equal to 3. So that is lower cost than the previous operation. So that means it always makes sense to match the characters of B with the rightmost characters, right? So that means, what does that mean? So suppose I have a large string S A B A B S A B A. Fine. And suppose I have this string. So this is my A, and suppose my string B is say A B A S. So it always makes sense to keep the positions as right as possible. So for this S, try to find the rightmost S where it can be matched. So look that S can be matched here. S could have also been matched here, but we will always try to match S to the rightmost S possible, because that keeps the number of operations minimum. Fine. So that means this S will get matched here. Okay. Now where can this A get matched? You would say that, okay, let me match this A with this one. This is not possible, right? Because we have to make this ABAS a subsequence of the string A, because we have to delete some characters from this A to finally get this string. So if I have to get this string, A should come before S. So I cannot match A with something which is later than this matched S, right? So this would not be possible. I have to match A something to the left of this S. So that means I have to match A with this A. Fine. So finally I have to match B with this B and A with this A. So this is the matching which I have to do. Okay, the matching is clear. Then what is the cost now? If you look at the cost, basically the cost of deleting this S is 1, right? That is fine. And these things we will not delete because they are already matched with B. What is the cost of deleting this B? Remember that when you delete this B, the string will have these 3 characters before them. So the index of this one will be 4, right? So the cost of deleting this is basically 4. And what is the cost of deleting this? The cost of deleting this is 5. Why? Because when you will delete A, the string will have A, B, A and this S A before it. So the cost of deleting this is 5. Similarly, the cost of deleting all these elements is 5 itself. Okay. So basically, if you think about it, like what happens? So you have to delete. So we have matched this. So how will we delete? We will first delete S. So if you delete S, you incur a cost of 1. Okay. So after you have deleted S, what string you have? You have this string A, B, A, B, S, A, B, A, right? Now we will not delete this A, we will not delete this B, we will not delete this A because they are matched with this ABA. We will delete this B again. When we will delete this B, what will be the index of this B? The index of this B will be 4, right? Because there are 3 characters already ahead of it. That is the reason we have added 4 as cost. Similar logic for all these other things. So that means, so what does that mean? How can we compute the cost? Computing the cost is actually easy. you just look at how many characters of B you have already marked. So like start from here. In the last, so if the length of B is 4, then that basically means that okay, I have to incur a cost of 4 plus 1, 5 for the last character. Okay. And then you keep on moving leftward. As soon as you match one character, then the value of the cost will decrease. So as you match characters, then the value of cost keep on decreasing. So here the cost is 4, you have matched 3 characters, so from here onwards the cost will be 1. Okay, so that is how the cost will be calculated. Let me show you the code, then probably it will be a bit more clear. So look at it. I have taken the strings A and B as input. Then I have taken N and M. N is basically the size of A, M is basically the size of B. That's fine. The pointer basically is M minus 1. So this basically points to the last index of B. So that is clear. And then if I see that, okay, if B PTR equal to AI, that means the last character of B has matched with this character of A. So in that case, we just reduce the value of pointer. So that basically means that we will look at a lower index, right? So this is something like this, that suppose this is where my pointer points at. So this is where my PTR is, and this is my AI. So if I see that okay, both of them are equal, so I reduce my pointer to this position. So basically now I will search for A and not S, because S has already been matched with this. Okay, so this is how it is simulated. I just check that okay, is B PTR equal to AI, and if it is, then I reduce the value of pointer. I do it only when pointer is greater than equal to 0, because if pointer is already negative, that means the entire string B has matched, and then we do not need to do this. And finally, if this is not the case, that means B PTR has not been matched with AI, then we need to basically increase the cost, and then I increase the cost with PTR plus 2. I hope that is clear, because look at the rightmost case. At the rightmost case, if the length of this is 4, then we need to add a cost of 5, right? But what PTR is? So basically at the rightmost case, we need to add M plus 1. But at the rightmost case, PTR is M minus 1. So that is the reason we add PTR plus 2 every time. I hope that is clear. So if PTR is greater than equal to 0, that means we have done this entire iteration. We have iterated over the entire string A, and still yet we could not match the entire string B. That means B is not present in A as a subsequence. So in that case, we print minus 1. Else we have already computed the result and we print answer. Okay, fine. So I hope that's clear. If that is the case, let us move to the next problem. So it says that you are given a binary array A of length n. Beauty of an array is defined like this. Okay. And then it says that you are given Q queries of the form, given index P and binary integer X, update AP to X and print the beauty of the array. Okay. Note that each query changes array, and after each query the array does not go back to original. Fine. Let me explain the problem once. So this is what the question says. So this question starts with this definition of beauty of an array. So it says that beauty of an array is something weird. It basically says that you take the bitwise AND of first 2 elements, then you take the bitwise OR with the third element. So you take the bitwise OR with the third element, then you take the bitwise AND of this with the fourth element, and then you keep on alternating this. So this is what beauty of an array A is. So that is what is given in the question. Now the question says that you need to solve Q queries. Okay, so you need to solve Q queries. In each query you will be given an index P, and you have to change this value. So basically in each query you will be given 2 values. You will be given P and X. So basically you have to assign AP to X. And then you need to find the beauty of the array and print it. So that is what the question is. Okay, fine. So now it is clear that the beauty of the array can be found in order n time, right? You can just iterate over these values, do the operations as required, and in order n time you can find the beauty of the array. But if there are q queries to be solved, that will take q n time, and this will be the brute force algorithm. Basically, for every query you make a for loop over the entire array and print the answer. But if you look here, it has been said that the sum of n and q over all test cases won't exceed 10 to the power 5. So that means obviously an order qn algorithm would give TLE. We need to think something better. So here is an idea. Like, if you think very carefully, look at this expression. So this is how the expression looks like. It is A1 and A2 bitwise or A3 and A4 bitwise or A5 and so on. Now look at this. What if this value is 1? Okay. What if this value is 1? If this value is 1, then this expression will be entirely 1, right? Irrespective of the values A1 and A2, whatever they are. Since we are doing bitwise OR with A3 and this value is 1, this entire value will be 1, right? Similarly, look at A5. If this value is 1, then whatever you do with the remaining thing, since you are finally doing a bitwise OR with 1, this entire value will be 1, right? So that means at odd indices, if you have a 1, then the final value will be 1. What I basically mean is that at an odd index, if you have 1, then the value of this entire prefix at least is 1, right? Similarly, at even index like A4, if you have a 0, here, then you are taking a bitwise AND with everything. So if this is a 0, then whatever be the value of this initial prefixes, the final value up to A4 will be 0, right? So this is the beauty of it. That means that if you have in an odd position, if you have a 1, then this entire value will be 1. And in an even position, if you have a 0, then this entire value will be 0. Fine. So now this gives me of an intuition. So basically, why not do it like this? So basically, I have been given an array, right? I have these values A1, A2, A3, and this goes till AN. Now at some index, so suppose I have this value AI, and suppose AI is even, fine. Suppose I is even and I have 0 here. So if I have 0 here, I know that okay, that means this entire value is 0. Similarly, if I have 1 here, suppose I is odd and I have 1 here, then I know that okay, this entire value is 1. So that means that the most interesting part of the problem, that means we can actually maintain a bag. What does this bag store? This bag store all the good indices. What do you mean by good index? So let me define what a good index is. So what is a good index? If I is odd, and AI is 1, I call it good. So this is the first case. If I is odd and AI is 1, I call it good. Similarly, if I is even and AI is 0, I call it good. Basically, in order to check good, the simple condition you can check is that is AI equal to I modulo 2, right? If I is odd, then I modulo 2 is 1, so AI is also 1, and if I is even, then I modulo 2 is 0, and then AI is also 0. So if you have to check that whether some index is good or not, you basically check that okay, is AI equal to I modulo 2. But why are these good indices important? My idea is, suppose I find the bag of all good indices. Okay, so suppose I have this bag of good indices. So I have 1 is a good index, 3 is a good index, 5 is a good index, 8 is a good index. What does this mean? This means, so look at this, take the largest value of this index, of these good indices. So 8 is a good index. So if 8 is a good index, so that means what is the value of 8? That must be equal to 8 modulo 2. That must be equal to 0. But if the value of A8 is 0, so if the value of A8 is 0, that means in that expression of beauty, the first 8 integers, that entire expression must be 0, right? So if the value of A8 is 0, that means up to the 8th expression, the entire value is 0, right? And after that there are no good indices. So larger than 8 there are no good indices. That means larger than 8 things are just alternating. So let me show with the help of an example. So suppose I have this value. So suppose this is the array. Fine. Let me also do the indexing. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay. Now let me maintain the bag of good indices. So which indices are good? Wherever we see that AI is I modulo 2, those are good indices. So 1 is a good index, 2 is a good index, 3 is also a good index. I see that 6 is a good index. And apart from that, I do not see any good indices. Just a second, let me confirm once. Yeah, that's fine. So I just see 4 good indices. So now look at this. What is the value till A6? If you compute, what is the value till A6? So you basically take bitwise AND of these two. So these are 0. You take a OR with this. So this is 1. Then you again take a AND with this. So this is 1. Then you take a OR with this. So this is again 1. And then you take a AND with this. So this is 0. That means up to the first 6 length, the value is 0. And we can also check that, okay, because 6 is a good index, that means the value till 6 is basically the value which is present here in the array. So this is why good indices are important. If you know that 9 is a good index, then you know that the value till 9 is nothing but the value which is stored in the array up to 9, right? And what is the beauty of this entire array? Note that the beauty of this entire array is also 0, because these are all not good indices, right? If you have not good indices, then they do not enforce any condition. Basically, if you have a not good index, what does that mean? So basically look at this. Here you are doing a bitwise AND. Here you are doing a OR. Here you are doing a AND. Here you are doing a OR. You are doing a AND. Here you are doing a OR. Here you are doing an AND. Right? Now look at this. You are doing an AND with 1. Doing an AND with 1 is useless. Like that does not changes the value. Similarly, you are doing a bitwise OR with 0. Bitwise OR with 0 is useless. It does not changes any value, right? Like x bitwise OR 0 always remains x. So that means if you have not good indices which are not good, then those are just not valuable. They do not change the value. That means what you need to do is, you basically need to maintain the bag of all good indices. You need to maintain the bag of all good indices, and whenever you are asked the beauty of the array, you just need to take the largest good index and check what is the value of this good index in the array itself. Why? Because all the indices to the right of it, those are not good, and if an index is not good, it does not enforce any condition. All the conditions it enforces does not are like trivial. So that is the reason it does not changes its value. Okay, so let me show you the code once. Probably that will make things a bit more clear. So look what I have done. I have taken n as input, the vector is input, then I have made a set. I have kept this greater LL because I would be requiring larger elements, for the largest element from the set. Okay. Now here I have maintained the set where I have stored all the good indices. Instead of I modulo 2, I did a I plus 1 modulo 2 here just to maintain 1 based indexing here. Fine. Now I am reading the queries. So I read the values of P and X. Okay. So if I see that, okay, the value of VP not equal to X, that means there is some change made and I have to reflect it. Fine. So I set VP equal to X. Okay. Now I see that, okay, was P a good index? If P was a good index, then P is now not a good index because its value has changed. And if P was not a good index, then that means P is now a good index because its value has changed. Fine. So this basically maintains my bag S. So this bag S is nothing but the bag of good indices. Okay. So if this bag is empty, then the value is simply V0. And if the bag is not empty, then you basically find the largest element in the bag, and the answer is nothing but the vector, the value which is stored in the vector corresponding to that largest element in the bag, right? So that is how I've implemented. The logic is exactly same to what I discussed. So probably it is clear. If that is the case, we will move to the next question. Okay, fine. So this is the next question of the contest. It says tactical removal. So the question says that the final score of an array A is calculated by repeatedly performing the following operation until the array is empty. Initially score is 0. So how do we perform the operation? It says that add the median of the array to the score and remove any element from the array. Okay, fine. So the question is, it says that Bob is given a permutation P of length n. Bob wants to minimize the final score of the permutation while Alice wants to maximize Bob's final score. To achieve this, Alice goes first, removing a contiguous subarray of exactly length k from P. The remaining elements are concatenated to form a new array on which B then operates. Okay. Now it says that both players will play optimally. Alice will always remove the subarray that maximizes Bob's final score, and Bob will always perform the operations to minimize the final score. Your task is to find this final score after both Alice and Bob have played optimally. Okay, fine. So let me explain the problem statement once. So the question says that in input, they give us an array of integers a1 till an and a value k. Fine. Now Bob is usually playing a game. Okay, the question says that they give us a permutation. Permutation. So that basically means that all integers are distinct and every integer is from the range 1 to n. So every integer is from the range 1 to n and all the integers are distinct. So that is what a permutation is. Fine. Now Bob is playing a game. How is it playing a game? It basically does something like this. It has this bunch of integers a1 to an. It adds the median to its score. So it adds the median to its score plus equal to median. And then it deletes any one element which he likes from the array. So it deletes any one element which he likes from the array. So suppose it deletes ai. And then it again keep on adding the median to its score. And Bob does this continuously until and unless this array becomes empty. So for example, if I have this array, suppose I have 1, 2, 2 and 4, then what can Bob do? First of all, Bob adds the median to its score. So it adds the median, so the score, it adds 2 to its score. Then it can delete any element. So suppose it deletes this 1. Fine. Now it has this array 2 to 4 with it. So again, what is the median? 2 is the median. So it again adds score plus equal to 2. It can now again delete any one element which it likes. So suppose it deletes this 2. Fine. So now what is the median? This is the median 2. So if this is the median, it again adds a plus equal to 2. And now it can delete any one element. So suppose it deletes this 2. Fine. So now this is the array which is left. So what is the median of this? The median of this is 4 itself. So it adds a 4 to the score and finally deletes this. So finally this entire array gets deleted. And what is the score which Bob obtains? So that is 2 plus 2 plus 2 plus 4, which is 10, right? So that is how the game is played. So Bob is playing the game like this and it is trying to get a score. Bob always wants to minimize his score. So it has been said that what does Bob wants? Bob wants to keep his score as small as possible. Okay. But now his friend Alice wants to keep his score as large as possible. Okay. But what is Alice doing? So the question says that in the beginning of the array, so in the beginning of the game, so when you are playing, what can Alice do? What will Alice do? Alice will take any subarray which he likes of length k and he will remove them. Fine. So Alice took any subarray of length k, removed it, basic, and then this entire remaining part are concatenated to create a new array, and Bob plays a game on this remaining array, right? Both Alice and Bob are smart enough, so they will play optimally. So that means Alice will always try to choose a subarray which maximizes the score as much possible, and then Bob will try to play it in such a fashion that the score is minimized as much possible. Okay, fine. So how can we solve this problem? So a basic idea is that initially forget about Alice, forget about whatever powers Alice has, and just think about what will Bob do if he gets a bunch of numbers. So suppose Bob gets a bunch of numbers A1 till AN. Fine. Then how should Bob play? So my question is, how should Bob play if he wants to keep his score minimum? How should Bob play if he wants to keep his score minimum? So now this is quite intuitive, that if he wants to keep his score minimum, that means what value does he add to his score every time? Every time when he is adding something to his score, he is basically adding the median to the score, right? He is making a score plus equal to median. So that means if Bob intends to decrease the value of the score, if he wants to keep the score minimum, then that means Bob has to basically try reducing this value of this median, right? So Bob has to do something so as to decrease the value of this median. Now how can the value of the median be decreased? A simple strategy for Bob is, so what can be a simple strategy for Bob if you want to reduce the minimum? So simple strategy for Bob is, every time what you do, you erase the maximum element from the array, right? So every time you erase the maximum element of the array. This is quite intuitive, that if you reduce the maximum element of the array, if you erase the maximum element of the array, then that is the only case when your median will decrease the most, and that is the only case when Bob will actually have minimum score, right? So look at these examples. So suppose the initial array is 1, 2, 3, 5, 8 and 10. Okay, so suppose this is the array which Bob has. Then what is the minimum score Bob will get? So basically, first of all, Bob has to add the median. So this is the median. So Bob has to add 3 to his score. Then it will delete 10. Okay, so when it deletes 10, then what is the new median? The median is again 3. Great. So now it deletes 8. Note that in order to minimize score, Bob always tries to reduce the maximum elements. Now, as soon as 8 is deleted, note that this median has shifted from 3 to 2. Now the new median is 2. So Bob will add a 2 to the score. Fine. Now the same thing will happen. You delete a 5. The new median again remains 2. So it adds a 2 to the score. Now you delete this 3. Okay. So if you delete this 3, the new median becomes 1. So you add a 1 to the score. Now you delete this 2. The median still remains 1. So you add a 1 to the score. And finally this 1 gets deleted. Did you see some pattern? Look that whenever you have an even length array, actually the minimum score you can get is nothing but double of the sum of this lower half, isn't it? Look, this is nothing but double of the sum of the lower half, 1 plus 2 plus 3, right? That means whenever you have even elements, so suppose you have A1, A2 and you have AN such that n is even, n is even, fine. Then what is the minimum score Bob can make? The minimum score Bob can make is nothing. Suppose this is the sorted order, okay. So if this is the sorted order, the minimum score Bob can make is nothing but 2 times A1 plus A2 and this goes till AN by 2. Fine. So that is basically that Bob can make the score of the double of the score, double of the sum of the smaller half, basically the leftmost portion, the lefter half. Fine. And what happens if n is odd? So let us look at this example when n is odd. So suppose this is an example. If this is the example, look at how the medians are calculated. Initially the median is 3, then 8 is deleted, so the new median becomes 2, and then you delete a 5, the new median still remains 2. Now you delete a 3, the new median becomes 1. Now you delete a 2, the new median again remains 1, and this is the answer. So that means when n is even, the answer is simply 2 times sum of lower half. Fine. And when n is odd, the answer is nothing but 2 times sum of lower half. But then note that if you take 2 times sum of lower half, so you basically have this 1, 2 and 3 added 2 times, but then you have to subtract this extra 3 because there is only 1 3. 3 has not appeared 2 times when n is odd, right? So you have to subtract this value. What do you call a n by 2 probably? So this you have to subtract. Fine. So this is clear that okay, if Alice was not there, how would Bob play? So that is clear that if Alice is not there, what will Bob do? The strategy for Bob is simple, that he always picks the largest element from the array and then calculates the sum. Okay, fine. Now what does Alice does? Now Alice comes and what does he do? So he has basically this array of integers a1 to n. What can Alice do is, Alice can take any subarray of length k and erase it, right? So if it erase these elements of length k, then basically what remains is these bunch of values. And then what is the minimum score Bob can get from this bunch of values? That is just you look at either it is the even case or the odd case, and then you simply find out 2 times the sum of the lower half, right? Now this is very interesting. There are 2 very important observations which you need to see. What are these 2 observations? First, see that you need to find, what do you need to find? You need to find sum of lower half. You need to find sum of lower half. Now always remember that this is a very standard idea. Whenever you need to try to find the sum of say lower half of a bunch of numbers, it always makes sense maintaining 2 sets. So whenever you have some set S and you need to find the sum of lower half, then try to maintain 2 sets. One is say S low and one is S high. Okay, S low, what does S low store? It stores the lower half of S, and S high stores the upper half of S. So basically what I'm saying is that suppose you have this S, which is the bunch of numbers say 1, 2, 3, 5, 8 and 11, then store it as 2 different sets, S low and S high. So this is S low and then this is S high. Fine. In S low you store these values 1, 2, 3. In S high you store this value 5, 8, 11. Okay. Note that these sets can be very easily modified also. Like suppose I need to delete this 8. Okay. So suppose I need to delete this 8. So if this 8 gets deleted, so basically check where is S present. Is it present? Where is 8 present? Is it present in S low or is it present in S high? It is present in S high. So you delete 8 from here. Very clear. Right? It's fine, right? Now suppose you also want to delete this 11. So you want to delete this 11. So again do the same thing. Look where is 11 present. Is it present in S low or is it present in S high? It is present in S high, right? So delete 11 from here. But now if you delete 11 from here, you have to always keep the size of S low and S high the same. So that means what do you need to do is, you basically take this maximum element of 3 and push it here. So now the new sets become like this, 3 and 5 here, 1 and 2 here. So this is a very standard idea. Whenever you are trying to say find the sum of the lower half or the sum of the upper half, or patterns like this where the lower half or the upper half is of interest, then try to maintain 2 sets S low and S high. And whenever you have to make some insertion operation or say deletion operation, handle it similarly, right? So like for example, in this same case, suppose 1, 2, 3 and 5, you need to insert a 21. So you need to insert a 21. So you need to check that, okay, should I insert 21 here or 21 here? So 21 is larger than this value. So you have to insert 21 here. But now if you insert 21 here, you have to push 3 back to this set, right? So these are a few cases which you need to handle. But at the end of the day, you will make a constant number of set inserts and set erasers basically. So that is how you can maintain S low and S high. So I hope that is clear. One more thing which is interesting is that you need to basically iterate it over all subarrays, right? So you have this A1 to AN, and Alice has the power to choose any subarray. So Alice can choose this subarray of length k, it can choose this subarray of length k. So there are many choices Alice can have. So how to find the minimum sum Bob can obtain for all these choices of subarrays? So here an idea of a sliding window based approach helps. So what is the idea? The idea is simple. So you basically first take suppose Alice has taken the first k elements. So if Alice has taken the first k elements, then these n minus k elements are there which are remaining for Bob to play with, right? Out of these n minus k elements, suppose you have maintained 2 bags, S low and S high. Fine, S low stores the lower half, S high stores the upper half. Clear? Now, when you try to shift this subarray one step to the right, so when you shift this subarray one step to the right, what you basically do is you insert this value ak plus 1 into the subarray, and you erase this value a1 from the subarray, right? So that means in this bunch of numbers, ak plus 1 needs to be deleted, and a1 needs to be inserted. If you do this, then you are basically shifting the sliding window by 1 unit. So these are constant operations. So these are order 1 operation, like order log n operations, right? You just need to insert and delete things from a set, and then you basically need to find the answer. So this is the basic idea. Probably the idea will get a bit clear if you look at the code. So here is the code for it. So I have maintained 2 sets L and R. So L stores the set for the lower half, R stores the set for the upper half. Then I take the vector as input, and then what do? I say that, okay, for all these values which are from k to n, that is, I have first kept the entire subarray of Alice to the left, and I have inserted all those values to the right, to the R set, right? But now from this R set, what will I do? I will pick one by one elements and keep on inserting them into the L set, so that basically the size of the L set and the R set becomes roughly equal. So now L stores basically the lower half and R stores basically the upper half. Fine. And then what is answer? Answer is nothing but 2 times sum minus this. So what is this flag? This flag is basically n minus k modulo 2. So this basically handles the even and the odd case. If n minus k is even, then this flag is 0, and the answer is simply 2 times sum as we discussed. And if n minus k is odd, then that means we basically need to reduce or take subtraction of the largest value of L, right? So that is what we discussed for what would be the minimum value Bob can attain. Fine. Now here we are basically shifting the sliding window one by one. So the idea is very simple. As you shift the sliding window one by one, this ai minus k, you have to insert this into either R or L, and this ai, this you have to erase from either L or R. Fine. Because this ai minus k is basically something which was not present in the present in the sliding window, but now you can insert it, and ai, which was initially not present in the sliding window, but now it will get inserted into the sliding window, so Bob will not play with it. So you just look some cases that where should I insert it? Should I insert it into R or should I insert it into L? Depending on that, you basically either insert it into R or L, and you also maintain this sum variable. So this sum variable basically stores the sum of the L set. So whenever you delete something from the L set, you reduce the value of sum. Whenever you insert something to the L set, you increase the value of sum, right? And here this is what we have done. So I basically, if I'm trying to insert some value, I just check that okay, is the value greater than else maximum value? If it is greater than else maximum value, I need to insert it into R. Otherwise, I have to insert it into L. So these are conditions which I need to check every time. So I find the answer, and then I take the maximum of answer with it, and I print the final answer. So the basic idea is that whenever you need to handle sum of lower halves, sum of upper halves of a set of elements, try keeping that set as two different bags, one for the lower half and one for the upper half, and then try to handle these cases yourself and try to find the answer. So that is the basic idea. And since here a sliding window based approach was very useful, because when you are basically sliding the window, you are just inserting one element and you are erasing one element. So that is the reason it helps in improving the time complexity. So that is what it was. I hope it was helpful. Thank you.